Good morning, everybody. I'd first like to thank the AusIMM for the opportunity to make this presentation. Particularly like to thank Mark Chalmers, the chair for the session and the chair of the conference, for everything it's done to make this possible and working with his committee. The AusIMM also needs to be commended for arranging this event and holding it here in South Australia. It's obviously an entirely appropriate location in which to bring together industry participants not only from Australia but from around the world. I say this because South Australia can now look forward to becoming the world's leading uranium province. I'll refer this morning to how BHP Billiton's Olympic Dam operations may be able to contribute to the state reaching that position. But you're also finding out during the conference about other projects that are either underway or planned, which would take South Australia above Canada in terms of total uranium production by the end of next decade. And as such, South Australia will make a significant contribution to the world's energy security and clean energy portfolio. The operations now underway or planned will ensure that Australia's uranium export performance gets much closer to being aligned with its true potential. One of the reasons these things can happen in South Australia is that the industry is well accepted both politically and publicly. There is bipartisan support from the major political parties for our activities, and we very much appreciate that. That said, the industry has worked hard to achieve this through high standards of safety and environmental performance, and recognises very well that high and ever-increasing standards of stewardship are critical to us maintaining and enhancing our reputation. And to that end, I would certainly commend your attendance at the launch of the AUA's Charter on Stewardship and its Code of Practice at the break after this session. South Australia has a very proactive state government which has strongly encouraged exploration and development. All the signposts are in the right direction to a growing, sustainable industry with the capacity to provide major benefits in an international, national and regional context. And for BHP Billiton, while uranium is a relatively newcomer to our portfolio, it is one which we believe will be a major contributor to the corporation in the years and decades to come. We enjoy an unparalleled resource position in the industry through our Olympic Dam deposit. Its potential keeps getting greater, as I will illustrate with reference to last year's resource numbers and talk a little bit more about the additional drilling that we've done over this year. The future growth opportunities for Olympic Dam are, of course, inextricably linked to the prospects of the nuclear power generation. I also want to spend some time in this morning's address in the potential for what some have called a nuclear renaissance. Before I do that, I need to draw your attention to what is becoming an even longer and longer disclaimer slide, which really is now covers 2 slides, but it gives some indication of the complexity of operating in the resources industry in the modern era where M&A activities certainly keep us all on track about what we say and how we say it. What I plan to cover today is to reinforce what a massive and superior resource we have at Olympic Dam and how well it positions us for the huge growth potential in the nuclear industry as the world gets serious about combating climate change and we begin to see China's significant impact on the industry. The reference to a nuclear renaissance implies perhaps that nuclear once experienced a golden era. We probably haven't been in the nuclear industry long enough to comment authoritatively about whether that's true or not, but there is, and in fact, whether there's any precedent for the kind of growth that nuclear power generation looks set to experience. Particularly for international visitors, I'd like to just set a little bit of context around Olympic Dam. The resource was first discovered in 1975. It's a unique polymetallic mineral deposit containing copper, gold and silver as well as uranium. And I'll illustrate in a minute why this is a world-class resource. So I think it is important that while I'm speaking about Olympic Dam in the context of uranium today, given the subject matter of this conference, it is a very major copper deposit and gold deposit in its own right. So while it already hosts Australia's largest underground mine, our challenge remains to transform this world-class resource into a world-class mining operation. When BHP acquired WMC and therefore Olympic Dam in July 2005, and assume responsibility for significant expansion that was already being scoped by its former owner. Mining of the resource began in 1988, and the mining method is sub-level open stoping. And for the past 20 years, underground mining has been concentrated in the northern section of the deposit. The current annual mining rate is around about between 9.5 and 10 million tonnes per annum. I'll refer in a moment to the drilling undertaken over the past 3 years, and insofar undeveloped southern section of the deposit on which the current expansions are now based. Currently, Olympic Dam processes all product to refine metal on the site, using a traditional flotation, smelting and refining process to produce high-quality copper cathode, gold and silver. And an additional hydrometallurgical and solvent extraction circuit allows for the recovery of additional copper and for the concentration of uranium as uranium oxide, maximising the recovery of minerals from the mined ore. Olympic Dam customer base, more than 70% of Olympic Dam's revenue, in fact, has historically come from copper. Now that's an artefact, obviously, of the volume, but also the respective realised prices of both copper and uranium. Most of our product is exported to the Asian market, and in uranium we have a diversified book spread pretty evenly across the Asian, European and North American sectors. The current focus on the expansion plans for Olympic Dam tends to overlook the fact that the existing operation is already of significant scale. And it also makes a significant contribution to the South Australian economy, as shown on this slide. If you look at the growth in resources over time, since BHP Billiton's acquisition of Olympic Dam, it has took an early important decision to undertake a major drilling program to better define the resource. Between 2005 and 2007, the drilling has almost doubled the Olympic Dam resource. Our 2007 annual report stated that the mineral resource estimate is now 7.855 billion metric tonnes of metal grades of 0.86% copper, 0.29 kilos per tonne of uranium oxide, 0.3 grams per tonne of gold and 1.6 grams per tonne of silver. This places Olympic Dam as one of the world's largest copper deposits, with over 67 million tonnes of contained copper metal and gold at more than 78 million ounces of contained metal, making this the largest gold resource in Australia. That estimate also confirmed that Olympic Dam is the world's premier uranium deposit, with more than 2.2 million tonnes of contained uranium oxide. Drilling has continued in the past 12 months, and a total of 487 surface and underground drill holes, totalling 192,000 metres of inclined and vertical drilling, have been completed. This brings the total resource delineation drilling for Olympic Dam ore body to a total of, I hope I get this right, 1.09 million metres of surface and 1.17 million metres of underground drilling. That's a hell of a lot of drilling in anybody's terminology. This drilling is expected to contribute to further increases in the mineral resource for Olympic Dam, along with improved confidence which will be demonstrated by an increasing proportion of measured and indicated resource. Notwithstanding the extent of the drilling, we have yet to determine the final deposit size. The mineralisation is still considered to be open laterally and at depth in various sectors of the deposit. The deposit covers an area of over 6 kilometres by 3.5 kilometres, with mineralisation intersected at depths of over 2 kilometres in some places. These results are impressive in every sense. They expand the resource base for the existing operation, improving the mineralogical and geotechnical understanding, and paving the way for the development of an open pit operation that will be readily expandable into the future as the growth in demand for uranium to fuel the world's growing reactor fleet kicks in. Let's just reflect on the Olympic Dam resource in a world context. It contains about 40% of the world's known uranium resources. It's the 4th largest copper deposit and the 5th largest gold deposit, all in the same rock. It's truly a world-class resource by any yardstick. and it's difficult to think of an equivalent deposit in any major commodity that remotely delivers such a privileged industry position. As we consider the outlook for the nuclear industry, let me focus on what it means in terms of our Olympic Dam expansion plans. Olympic Dam is the perfect asset to have in the potential scenarios that I will outline in the remainder of the presentation. That is, it's already in the portfolio, it's in a first world country with an existing operation in place and huge growth potential. Our drilling program has identified the opportunity to optimise the existing underground operation, and this will increase the annual copper production to around 200,000 tonnes and increase uranium to 4,500 tonnes per annum. And subject to necessary government and investment approvals from the corporation, phases 2 and 3 will see us begin to construct a massive open pit operation and build more concentrating capacity, selling the additional copper concentrate produced with a resulting production of 350,000 tonnes of copper, 9,000 tonnes of uranium in the form of U3O8 and 400,000 ounces of gold. A further phases 4 and 5 will see us continue to enlarge the scalable open pit and match it with more concentrating capacity, selling the additional copper concentrate produced, and the combination of these stages would take production to the equivalent of 730,000 tonnes of copper, 19,000 tonnes of uranium and 800,000 ounces of gold. In emphasising that this is an expansion in an existing asset in a stable, well-known operating and fiscal environment, there is no reason to believe that the resource base would not support additional expansion phases above those that I've already outlined. What I'd like to do now is to move on to talk about some pertinent aspects of energy demand with a focus on what we see happening in emerging economies like China. And I think also as I speak it's interesting to put that in the context of the energy situation in this country and the events of the last few weeks, which obviously has put energy right back on the front pages again, a place that I think it will stay for a long time. Put simply, the world has a tremendous and increasingly insatiable demand for energy, and this is just the beginning. This shouldn't surprise given the laws of large numbers and the aspirations of emerging economy citizens. Combining the two factors, and it produces what you see on this slide, and that is that the resources are needed to produce as much energy in the next 20 years as that was consumed in the last 100 years. The population side of the equation isn't in question, so it becomes really driven by a belief around the ability of the Chinas and Indias to sustain the rural to urban transition that's received so much commentary. We believe this is both a social and economic imperative. Notwithstanding the current economic gyrations in the West, we remain very comfortable that the economic transition in China particularly remains on track. Looking now at energy intensity, we've seen many of these sorts of charts produced before in respect of metals demand, but it's important to keep in mind that they apply equally, if not more so, to energy. And this has important implications in the carbon aspects of what I'll discuss in a moment. It is not realistic to think that the planet will curb its energy consumption significantly as China and other emerging economies see their large populations emerge from poverty. China's use of primary energy per capita is less than 1/3 of Japan, South Korea and Germany. And in per capita terms, it's 1/5 that of the USA. So under any plausible scenario, it seems to be set to more than double in the next 20 years, which would still see it less than those other countries. China's real GDP per capita will quadruple in the next 20 years to reach US $15,000 per capita beyond 2030, and that assumes real economic growth rates in China of about 8%, which is less than we've seen in the last few years. I guess on this slide it's probably pretty difficult to even see China and probably impossible to see India, which are right, that's India there and that's China. So you can see in terms of their per capita consumption, there's a long way to go before they approach those other countries. If you look at China's power output, with its accelerating economic development, China's growth in energy demand has begun. This slide highlights the dramatic growth in power output in China in recent years. In terms of power produced, China's annual growth in 2007 is above the entire output of the UK. A China power study undertaken by BHP Billiton identified a range of possible outcomes for China's power output in the next 25 years. Under the most efficient and highest technology scenario, China will more than double its power output from 2,800 billion kilowatts in 2006 to more than 6,500 billion kilowatts in 2030. This is the most optimistic outcome in terms of efficiency and emission control. And CO2 equivalent levels will still only be just below the international expected levels for China of about 7.5 gigatons, or 36% above the 2005 levels. A doubling of China's per capita energy use would necessitate a substantial improvement in energy elasticity. If the relative contributions from coal in the energy mix stayed at today's levels of about 70% of the primary energy use, this would entail a combustion of almost 3 tonnes of oil equivalent, or 4.5 tonnes of hard coal per person. Under this scenario, China's coal consumption would rise from about 2 billion tonnes in 2007 to more than 6 billion tonnes by 2030. And if you assume 2 tonnes of CO2 are produced per tonne of coal, which is about right based on the coal mix used in China, emissions would total 12 billion tonnes a year of CO2 by 2030. In 2006, China surpassed the USA in terms of CO2 emissions at 6.2 billion tonnes. So the point is that the magnitude of the numbers in the equation is so overwhelming that if even a substanding forecasted error applied, the carbon load just can't be contemplated in a world which is determined to address the emissions issue. You don't have to be a rocket scientist nor even a nuclear physicist to work out that nuclear must play a major role in the mitigation process. Of course, as well as carbon capture technologies and initiatives to accelerate energy efficiency. There is no single solution here, but it is clear, as the previous speaker noted, nuclear must be a part of the solution. So, perhaps a second on what are the drivers of the global energy equation. And these are applicable both in China and the West. The energy challenge will need to be fought across all elements, and ultimately there will need to be an acknowledgement of the clear superior performance of nuclear in the power generation element of this equation. I've explained how Olympic Dam is simply in another league when compared to other uranium resources around the world. Why is this so important in the future? Well, the world map of nuclear power stations shows us 4 stages of nuclear development. The 439 black dots here currently show the current operating reactors that are mostly in the US, Western Europe and parts of Asia. The blue dots, pretty hard to see, but they're the ones currently under construction, 33 of those. 94 green dots, which are the reasonable level of commitments with budget or advanced plans for new reactors, mostly in East Asia, especially China, Japan and Korea. And 222 orange dots, denoting the reactor builds proposed in countries thinking about adding nuclear capacity against the CO2 backdrop. So this picture highlights the global significance of Olympic Dam. It's perfectly positioned to help meet the world's growing energy needs. If you look at the position in China at the moment, there's limited scope for more Three Gorges type projects. Large hydro, where possible, has already been constructed and is less environmentally friendly than it was first thought, particularly with large numbers of people having to relocate it. For Chinese authorities, in the near term, it's more about the choking impact of air pollution and dangerous particulate levels than it is about absolute emission levels. Local pollution issues are now of a serious nature and a pressing concern, and nuclear power can also play a leading role in reducing local molecular pollution issues. I'll now turn to the nuclear industry's role in addressing climate change and the impact that the realistic pricing of carbon has on nuclear economics. I'll also contemplate the potential impact that China may have on the nuclear industry and the uranium market. You can see that even in the West, based on assumptions from the Cambridge Energy Research Associates, based on coal, gas, nuclear economics, are pretty much awash at the moment under a no carbon cost environment. That's the first chart. Clearly the mix of those options is different, with nuclear having the highest capital cost. If you add a real price for carbon, I guess you could think about it as a waste disposal price in a sense, of US $30 and US $50 per tonne of CO2, and nuclear is highly competitive even in the West. In fact, at a price of $50 a tonne of CO2, it's roughly the same on a US megawatt hour basis as the entire capital burden of a new coal-fired power station. So BHP has developed a set of potential China power scenarios that estimate the number of nuclear stations that might be built in China. We've been running some what-if scenarios. How many nuclear power stations would need to be constructed if China were to move to between 25 and 30% of nuclear in their energy portfolio? We'd like to stress that this is for what we believe is a CO2 constrained scenario, and that governments move actively to promote low carbon technologies by means of a portfolio of incentives. The implications of these scenarios is that the call on uranium production will be huge, much higher than is currently estimated by the analyst community. In one of our internally developed scenarios, the power surge scenario, China has the potential to be the leading contributor to global CO2 emissions, with 41% of the world's global growth. In order to limit global warming to less than 2 degrees, the world will have to abate around 27 to 29 gigatons of CO2 over the next 20 years. 7.5 gigatons of that are expected to come from China. 1/3 of the new CO2 emissions are likely to come from China in the period 2008 to 2030. Nuclear power can reduce this impact substantially, we believe by up to 50%. We think it's important to look at the potential and the lessons that are being learned by how China is actually rewriting the capital intensity in a number of industries. There are a few examples here, a few out of my most recent past responsibilities in the aluminium and alumina industries, where we see that they've fundamentally rewritten both the capital intensity and the construction lead time. We've seen similar things happen in copper and steel and pretty much any other metal that you want to talk about. And it's not limited to relatively low-tech technologies. China rolled out its first regional jets recently and has very public ambitions to move to wide-body jet production. It's plausible to think that they could substantially reduce capital intensity of reactors and lead times through the creation of their own hybrid technology, modularisation and fast-track permitting. We believe the answer to those questions is a resounding yes. The only question is, when? As I suggested earlier, Olympic Dam is the perfect asset to have in these potential scenarios. We've often spoken about our desire for simplicity in our portfolio, owning few, large, expandable assets with decades or even more of life. There's no better example than Olympic Dam. It's assets like this that allow us a manageable business. Escondida, our copper mine in Chile, is a good example of a large Tier 1 deposit. It's interesting to note, though, that Olympic Dam now contains more contained copper than Escondida. Its development is an excellent example of the value of modular concentrate export driven by expansion strategy. From the commencement of production in late 1990, there has been a series of expansion decisions increasing production as growth in custom concentrate and copper demand is warranted. The economics for a large open pit are clear. Once the infrastructure and open pit have been developed, there are usually several subsequent expansions as the resource can be attacked in a repeatable, scalable fashion, building off the already installed capital base. Olympic Dam is a superb resource and unique asset, perfectly positioned in an industry that is poised for an unprecedented growth in energy demand in the world, with few realistic options to combat the growing carbon inventory other than nuclear power. China is set to significantly shape the future of nuclear power as it rewrites the rules on reactor capital intensity, permitting and construction lead times, and addresses the unsustainable nature of growth in its fossil fuel power generation sector. We think the future looks bright. Thanks for your attention. We are running a little behind, but I'm happy to take a question or two.
I actually have a question.
Yep.
Sorry,
Over here. It's just...
Yeah, Monica Sada from the AusIMM. I was just thinking, given the high initial capital costs and the risks involved with startup, and given that nuclear power will play such an important role in emerging economies, do you think there's scope in a post-Kyoto sort of 2012 commitment period framework to have incentives in there for developed countries to assist developing countries with their new nuclear build, and what would need to happen, I suppose, in the global political framework for that to happen?
Oh, that's a very interesting question. I think that there's an increasing amount of debate about whether nuclear should be part of the Clean Development Mechanism as an example. When you look at the history of why it isn't, I guess I'm no great historian in this area, it would seem when you start to look at the numbers, as I've demonstrated today, that there certainly is a case for recognition of the fact that clean mechanisms, wherever they come from, need to be part of the solution. And I think our industry has a responsibility to certainly advocate that, and I know that there were some papers delivered yesterday along those lines as well. So I think yes. I think the issue around greenhouse gas needs to be looked at both a local and a global perspective. And at this stage, obviously, there's perhaps more focus on local than global.
Graham, Ross Lothian, given that the studies for expansion of Olympic Dam are progressing, is it now an inevitability that it will be an open cut? And if so, can you give us some ideas as to when decisions will be made and what the planning is?
Yeah, look, given the scale of the resource and the additional confidence that we have with the resource work we've done over the last couple of years, as I said, the understanding and the size of it is now more than double what it was back in, I think I said 2005. That all supports an open cut, as does, we believe, the market, as I demonstrated before. In terms of time frame, it's the same position as what we've reported publicly over the last few months. That is, we are still in what we call our selection phase, which is, in other people's terms, pre-feasibility. As we've gone through coming to terms with what is the right development path, recognising the scale of the resource, this is the resource that will support many, many stages of development over a long period of time. So as you get to understand the resource better and better, you need to determine what is the right development path. So this is not a one-shot expansion. This is taking the right steps on decades of taking the right first step on decades of expansions. That pre-feasibility study will be completed before the end of the year. In a similar kind of time frame, we will complete the EIS. Obviously, the EIS is dependent upon the configuration coming out of the pre-feasibility study. We will submit that to governments. The environmental approval requires, under the EPBC Act, requires the approvals at both state and federal level. That EIS should be available for public comment during next year, once the government is satisfied that it meets the guidelines that were previously set. During 2009, we will also move into the detailed feasibility, or what we call our definition phase, and we would expect that early in 2010 that would be in a position to determine the way forward. Given the outcomes of the EIS and government approvals processes, our board would then be in a position to make the necessary decisions. Recognising that those environmental approvals processes, there's no guaranteed fixed timelines on those, but that's the same with every project.